Hey, hi, Rajan this side. Welcome to my YouTube channel. I'm creating a video after a very long time. So yeah. So today's was LeetCode Weekly Contest 457. Let's see what are the problem asked in today's contest. This is the first problem asked in today's contest. So it says you are given three arrays, each of length n, code, business line, and is active. And so code of I is a string that represents a coupon. Business line represents its category, and the third is active, whether this coupon is active or not, right? So you have to return all the valid coupons, and the valid coupon says that like the definition of valid coupon is that your code shouldn't be empty, and it shouldn't be empty, and it consists of all the alphanumeric characters a to j small, a to j capital, and 0 to 9, and an underscore. So if the coupon consists of these characters, then it should be considered a valid code. Now for a coupon to be considered as valid, the second condition is that your business line should be among one of these four, right? And the third condition is that it should be active, right? So we have to return all the valid coupons, but in a sorted form. And how we are going to sort it? Based on these four categories first. Like your electronics category should, like all the coupons which belongs to electronics category should come first, then grocery, then pharmacy, then restaurant. Now the second condition is that if they are of the same category, you should sort it based on lexicographically, right? So it means ascending order if they are of the same category. Otherwise, sort it based on their category first, and among the same category you can sort it based on the lexicographical order. So yeah, this is pretty much about this problem. Now let's look at how we can approach this. This is the code of first problem. This problem is pretty much an implementation problem, so I'll directly jump over to the code. So uh, so in the problem it says we will be given three vectors of string: code, business line, and is active. So now let's filter out all the valid coupons. So what I did here, I first check if your code, like if your current code is not empty. If it's empty, don't do anything, just continue, right? So the second condition was that it consists of an all the characters in this code should be alphanumeric. So I just check that if your all the characters are a to j small, a to j capital, or 0 to 9, or underscore, right? So this is the variable. So I declared a variable is valid, which would tell me that whether the current code is valid or not. Now the second condition was that it should be active. I checked that. The third condition was that your business line should be among these fours, right? So I just created a function that would return me if the current business line is either one of these four. So I just added that condition. Now if all the conditions satisfies, now push this current code and business line into this array which I created, which consists of pair of string comma string for the first business line, and the second one is code. The reason why I use it, because we have to ultimately return in a sorted form, right? And the sorting condition is based on business line and your code. That's the reason I use these two information. I just right now, if you see in the problem, it says that you have to first sort it based on the business line, and the order is electronics, grocery, pharmacy, and restaurant. But if you notice it here, all these four first characters are unique and is sorted in alphabetical order. R is more than P, more than G, more than E. So if you can just sort it, so see, if you do a sort function, it's sorted based on the first element of the array, right? So if you do a basic sorting, it will ultimately solve your problem. The reason why, it would sort based on like the lowest first. The lowest is E, then G, then P, then R. So it's, I mean, the byte, like the default sorting is actually the problem statement. Sort it based on that. Now the second condition, if you remember, was if they are of the same category, you have to sort it based on lexicographically. But the function itself does lexicographical sorting, so it's a default behavior, so you don't have to like kind of spend any time regarding thinking about those sorting, that how do I sort based on category and then lexicographical. Your default sorting would take care of it. Now just sort it, and once they are sorted, just return the code, the coupon code. So I just traverse through this all the valid coupons after sorting, and just I return the answer. So yeah, now let's look at the second problem asked in today's contest. So this is the second problem asked in today's contest. So it's, if you have noticed, this problem is actually a graph problem. Let's see what it says first. So you are given C number of power station, and each which unique ID from 1 to C. Now all these stations are interconnected with a bidirectional cable, means undirected graph, right? And the graph consists of UI, like between UI and BI. Now, so initially all the power stations are or online, I mean operational. Now we have given two kind of queries. The first query is that the first query is 1 comma x, so we have to return. So it's ultimately a maintenance check. What it says that if the station x is online, just return that station itself. Otherwise, all the stations which are connected to x, return the minimum power station among them. If you see the smallest ID of the power station among them, and if none of them are operation, return -1. And second one is that 2 comma x, if it is given in the form of 2 comma f, just off this power station, I mean make it non-operational, right? And at the end you have to return the answer for each query of type 1 comma x. So yeah, so this is actually a graph problem, and the exact algorithm which I used to solve this problem was Disjoint Set Union, DSU. So I'll explain how we can approach this problem. So let's say there are two groups of power station which are connected to each other. First is this group, second is this group, right? So before doing anything, all the power station are operational, means online, right? Online. Now so we have given two types of queries, right? 1 comma x and 2 comma x. So for 2 comma x, you just have to make power station of ID x offline. Make it offline. If it is given in the form of 1 comma x, you have to eventually so you have to first check if x is itself is online or not. If x is online, return x. Otherwise, if x is offline, you have to return the minimum ID among the group which are connected to each other. Like let's say your one become non-operational, right? But you are given a query of type 1 comma 1. So you first check if one is online but one is not online, right? So we have to, and this is the group which are connected to each other, which is connected to one. We have to return the minimum among these groups which is online, the minimum ID among these group which is currently online, right? So currently, let's say after 1, 4, 5, 6, 2 and 3 are online, your answer should be 2. Let's take a second condition. Your 1, 2 and 3, all these 3 are offline. Now your answer would be 5. The minimum ID of a power plant which is online currently. So the answer would be 5 if 1, 2, 3, all these 3 are offline. So now let's quickly see what is Disjoint Set Union. I would highly recommend to learn this algorithm because this is a pretty much used everywhere. I mean, I have seen most of the coding round, at least one question consists of the DSU algorithm. So it's better to, you know, to have a command on this algorithm. So I'll quickly explain what it does. So in DSU, it's called Disjoint Set Union. It actually forms a group in the graph. So let's say you are given a graph, this one, this is your given graph, right? This is a disconnected graph, by the way. So it creates a group among them. It kind of treat this as one group, these as second group. Let's say you have one few more nodes, this is the third group, this is fourth group, right? It so what it does, it actually creates a representative element among all the groups. So there would be an representative element of that group. Now it's up to you which element you want to make it as representative. It could be your mean element or the max element or any of the random elements. So I mostly choose the mean elements. What it means that, let's say the IDs are 1, 2, 3 and 4. So the so see, each node would be having, let's say for each node I, you would be having a parent of I. What it means, let's say I chose minimum element as a representative element of that group. It means that all these numbers would be pointing to the minimum element. It could be directly or indirectly. Means that if you do a kind of DFS, you would ultimately reach to the minimum element, right? So it's for each node, so let's say if this is the minimum element itself, it would be pointing to its own number, right? Because the parent of I would be I for the minimum element. Otherwise it would be pointing toward the minimum element. Similarly here as well, let's say this is 5, this is 6, let's say this is 7, 10 and 8. So it would be like this, right? And this is the single node, so it will be pointing to itself, right? So this is how your DSU is found. Now let's see how we can use this algorithm in our, like, to solve this problem. This is the code of second problem. So in Disjoint Set Union algorithm, we kind of use two kind of function. One is union and the second one is find. Let's see what each does. So the find function returns you the super parent. As I mentioned, it, like, ultimately in that group, all the nodes would be pointing toward the representative element. In my case, I chose the minimum. It means that all the nodes would be pointing toward the minimum element. So the minimum element could be either directly connected or indirectly connected, right? It could be via some path. For example, 4, it has to go via 3, then 2, then 1, right? So it so the find function returns you the super parent. So I first check if the parent of x is equal to x. It means that if the parent of x is that number itself, it means that it's the representative element. Otherwise, you return the super parent. I mean the parent of the parent. So it would ultimately reach toward the representative element. It's a pretty much a standard implementation of the union find DSU algorithm. So you can, like, take a look from Geeks for Geeks or any other online tutorial or website, right? So this is your find function. Now let's check the union function. So let's say you want to connect node A and node B. So first find the super parent of A. Now find the super parent of B. Check if both are different. If both are different, so if your A is greater than B, I just swap it because I want A to be the minimum, and now make parent of B equals to A. It means that I am pointing toward the minimum element because now A is the minimum among A comma B. So this is the union, this is find. Now let's see how we can use this like knowledge to solve this problem. So first I created the parent. Now the size, since this is a 1 base indexing, so I used n plus 1. And this is an iota function in STL, which essentially makes parent of I equals to I. So parent of 0 equals to 0, parent of 1 equals to 1, parent of n equals to n, right? So you don't have to write a loop for that. Now for each of the ages, I connected them first. So I just call this union of, like, make a union of v0 v1, which is essentially u comma v of that age. Now what I did, this is an interesting, because see, I mentioned for each group you would be having a representative element, right? So what I did, I've created a collection of, let's say this is my representative element. It would be consisting of some number, right? For example, in this example, 1 consists of 1, 2, 3 and 4, right? Similarly here 5 is the representative element, so 5, the collection would be 5 comma 6, right? So I just created this collection here. For each representative element, find of, for each, like for all I from 1 to n, find of I would give me the representative element in dot insert of I. So for each representative I created a set that consists of all the IDs which are connected to each other, or which are pointing toward this representative number. This is my answer. Now I am going through all the queries. First, find the representative of this current number, q of 1, because q of 0 would be either 1 and 2. So if it's 1, it means that you have to kind of return an answer for it. Otherwise, if q of 0 equals to 2, it means that it's a query of second type. So in second type, if you remember, we have to make it offline. So I just remove that from that collection, mp of x dot erase. So I just clear that because I want to make it offline, right? And if it's a query of first type, first check if your current group is empty. If your current group is empty, it means that all the nodes in that group is offline or they don't exist. So just your answer should be -1. The second condition is that check if the number itself present in that collection or not, right? If the number present itself in the collection, you have to return that answer. If you remember, in the problem statement it says that first check if it itself is online or not. So if it is online, it would be present in the collection, right? So return that. Otherwise, return the minimum among all the connected power plant which are online. So ultimately, this collection would give you the list of the set of those power plants which are currently online, because once it is offline, I just remove it from the collection. So whatever IDs which are present there, that all these are online. So if that is the condition, just return the minimum among them. That's the reason I use set here, because in set you can easily erase, insert and search, right? You can quickly search it, you can quickly find the minimum power plant which is currently online, and at the end return answer. So this is the solution of the second problem. Now let's look at the third problem. This is the third problem asked in today's context. So you are given an undirected graph of n number of nodes, indices from 0 to n minus 1, and you are given certain ages, and for each age you have 3 parameters, u, v and time. Means u and v is connected to each other, and after time t, this age would be removed, right? So you are given an integer array k. Now, so initially the graph could be connected or disconnected, that is fine. Now you have to return the minimum time such that after removing all the edges of with time less than or equal to this time, and like once you remove all these edges whose time is less than or equals to t, the graph contains at least k number of connected components. Okay, and this is the definition of connected components. Let's see how we can approach it. So if you look at the problem statement closely, you would find a monotonic behavior. Now let's see what is that monotonic behavior. So you have to ultimately find the minimum time by which if you remove all the edges whose time of I is less than or equals to 2, if you remove all these, so let's say after removing you got certain number of edges, if you connect them, your number of connected components should be at least greater than or equals to k, right? You have to return the minimum time. So let's see what if like if I take t is equal to 10 to the power 9, very large number, it means that you have to remove all the edges, right? Because time of I is only up to 10 to the power 5. So if you take a very large time, you have to remove all the edges, because all those edges would be following this condition. It means that once you remove all the edges, you would ultimately left with n number of nodes, right? N number of nodes which are not connected to like none of them connected to none of them. So your number of connected components is n. Now let's see if I reduce this time. Let's say your time is now 10 to the power 4 or something, right? And you got, and like after removing all the edges whose time is less than or equal to 10 to the power 4, you still got some edges which are connected to each other, right? What will be the number of connected component? I claim that now if you reduce the time, your number of connected components would be less than or equals to n, because there might a chance that you still get some of the nodes which are connected to each other. So if any of the node is connected to each other, your number of connected components is going to reduce, right? So how it forms a monotonic behavior? Let's say I've created a graph between time and number of connected components. If your time is very high, your time is very large, as I mentioned, if your time is 10 to the power 9, the number of connected components is n, very large. Once you reduce the time, your number of connected components is going to reduce for sure. So this is a monotonic graph, right? If your time is very large, your number of connected components would be n. Otherwise, once you reduce the time, your number of connected components is going to reduce. The reason behind, once you reduce the time, there might a chance that few of the A's, you have to keep few of the A's, right? Because I mean, you have to keep those edges whose time is greater than this time, your current time, your chosen time. So there might be a chance that few of the nodes are connected to each other. So if that is the case, if few of the nodes are connected to each other, your number of connected components is going to reduce. So once you reduce the time, your number of connected components is going to be less. So it's a monotonic behavior. So we can use a binary search here. What we can do, for let's say I choose this t, I would first get all the edges whose time is greater than t. Let's say this is the graph, right? Let's say this is the graph. So these are the edges whose time is eventually less than this t, right? So number of connected components is 2. I would first check if the number of connected components is greater than or equals to k. If that is true, it means that this is a valid time. You can take this time. And if you take this time, there is no point of going afterwards, right? Because if you go afterward, your number of connected components is, we know that your number of connected components is going to increase if you go beyond t. So it's better to keep it in this half of the time, because you have to retain the minimum time, right? So if you're like for this particular time, if you get your common number of connected components, now be in a left half. Otherwise, if that is not true, let's say you like for this t, your number of connected components is less than k. So now you have to go in the right half, because if you reduce the time, your number of connected components, we know that if you reduce the time, the number of connected component is going to reduce, right? So if your current age itself is very less, you have to make it more, right? Like you have to increase the number of connected components. So you have to go to the right half, you have to increase the time. Let's see how we can implement this problem. So this is the Yeah, this is the code of the second problem. I first chosen the low and high. If you remember, for a binary search we would need low and high. Low is 0 and the high is the maximum time among these edges. Now this is my answer. I use a binary search, standard binary search. Low is less than or equal to high. I found the mid. Now what I did, I am creating a graph based on all the edges whose time is greater than this current time. This mid is my current time. The reason behind is that otherwise, you see, you have to form a graph only for those edges whose time is greater than my current time, because by this time your all the rest of the edges would be removed. If you see in the problem statement, it says that your edge would be removed by that particular time. So if it is more than my current time, it means that you can consider it. This edge is still active. So I created a graph. It's unrated graph, so I used adjacency u dot pushback b and v dot pushback u because it's unrated graph. Once you create a graph, this is your visited array. Now this is a very much standard algorithm for finding a number of connected components by using DFS. So you just go and check if the not if like, so this is a visible array if your current node is visited or not. If this is not visited, you increase the number of connected component and you do a DFS. So this DFS would take care of visiting all the nodes which are connected in that group, right? Ultimately you check if your current number of connected component is greater than or equals to k. So if it is greater than or equals to k, no need to go in the right half, be in the left half. Your answer would be mid. Now your high become mid minus 1. Otherwise, if your c is greater than k, if you're like this condition would come when your c is less than k, you don't have to go to the left half, go to the right half, because the graph is increasing, right? So you have to go to the right half and ultimately return answer. So this is the code of third problem. This is the fourth problem asked into this contest. So you are given 2 points s comma t and x and y coordinate for these 2 points. You have to start from point s. Now at any point you can move to either of the these two position, and these two position are defined by x plus m comma y or x comma y plus 1, and where m is the maximum among x comma y, and ultimately you have to return the minimum number of moves to reach at point t, and if it's impossible, return -1. I don't have a code for it right now, but this is pretty much a standard dynamic programming problem, dynamic programming on a 2D matrix. So let me know if I should like create a solution video for this. I don't have a code at the moment, so yeah, like write in a comment if you want a solution for this problem. Thanks. If you find it helpful, please subscribe to my channel. Thanks for watching.